All right, today I want to kind of go over the structural geology lab. I had a couple of students asking questions about what exactly we're going to be doing. And what we are going to be doing is trying to figure out what the rocks would look like looking at a box diagram. A box diagram is something that looks like a box. Most of the time when we look at maps, we're thinking of just the top surface of this map, but we want to talk about what's happening on these sides and describing these in this diagram. So instead of looking at just map view, we're going to be looking at these side views or cross sections. So the first couple of diagrams or pages are going over those. What is a block diagram? It's a block of the earth. What's a cross section? It's a side view. What are the different types of faults? And from the chapter on earthquakes, we are going to talk a lot more about these different types of faults and the bends of the rock. We'll look at these things like anticlines and synclines in this week's lab or this week's lecture. Put some extra visuals on there. So the latter part of this lab is dealing with this thing called strike and dip. Now, geologists use this little compass, and this compass has a number of different things in here. And one of the things it has is a protractor that's on a level, and I can move the level around with a little lever in the back to figure out what the angle at which the rocks are tilting. So if the rocks were tilting like this, I'd set this on here on the rock. I could figure out, read the number out at the bottom, how much these rocks are tilted. We call tilt of the rock dip. And so we can actually measure how much these rocks are tilted from the ground, from horizontal, how much these rocks have been altered. And so I really encourage you to use the extra video that talks about that strike and dip, how to measure strike and dip that's already been created in your instructions. Now, when you are completed, so after you've read all of that information and watched the video on how to measure strike and dip, what you're going to end up making is something that looks like this for each of the pages on the back. What you're going to be doing is using the strike and dip symbol to determine what the other sides of these samples are going to be looking like. And you're going to be matching up those sides. Then I have a glue stick in the lab kit that you can connect these. Let me quickly connect my samples here. Quickly use a stapler instead of a glue stick, but any adhesive would work. Now, the instructions say that you don't have to color these. I really encourage you to color these shapes. They do mention that you can. I do have colored pencils in the lab kit for you. So when we start looking at this sample, we can see that we see kind of this rainbowed appearance where the rocks on one side are bowing up like this anticline. How did I know that the rocks are doing this tilt? Well, I use that strike and dip symbol. And so then part of what you're going to do is show me an image, maybe something like that. Take a screenshot of it or a camera image of this and throw it into, I've had a lot of students have a lot of success throwing it into a Word document. But if you want to upload each one of the images of your block diagram, don't just send me this side or just this side. Make sure I can see all sides, or at least 3 of the sides of your box diagram. This would be an east-west face, this would be a north-south face, and this would be the map view of these rocks. So if we can identify this sample would be a plunging anticline. And so I would label that as a plunging anticline. So I'd write that on the kit, or on the sample, write down plunging anticline, and then I can see which one is which because I can see the top with the samples already given to you. So on the first box, it's not a real sample, but you can see those stripes, and we can see the side view, what it would look like. Your goal on that one is to make sure that I can see what the angles of dip are using a protractor and measuring those. You have a protractor in the lab kit, so make sure you use it. To use a protractor, you're going to be putting this little dot right in the middle, right on the apex of this curve. So if I were measuring this angle, I would have to extend this line down, and I would see that this rock is dipping at about 50 degrees to this direction. Look at a compass to see what direction that would be. And so if you have any questions about this, please let me know.